I hope all of you have opened the PDF. Yes, sir. Okay, okay. 1 minute. Okay, so in the you open the PDF, and in the first page you can see there is a diagram of singly reinforced beam is given. Is it? Can you see that? This is the diagram of the beam which we have designed in the last class. Okay, so I hope all of you can see the screen. Okay, so can you see the screen, all of you? Is it clear?
Yes, sir.
Okay, so in this figure, this diagram is this is the beam which we have designed in the last class. Means in the last class we have designed a singly reinforced beam, and for that beam, after designing the beam, you have to draw this kind of diagram. This is a very simple diagram. You can see according to the according to the question, it was given that the clear span between the supports was 6 meter. So this is one support, this is one support. So you can see the clear span is 6 meter. This is your clear span. Then it is also given the width of the supports was 230 millimeter. This is 230, this is 230. Okay. Then after designing, we have got that the distance between the stirrups will be 300 millimeter, because the other values are more than 300 mm. So we will provide 300 millimeter center to center distance. Okay. So this is these are the stirrups. These are the vertical stirrups. Okay. So and the distance between them is 300. Okay. So you can see here it is written here also, two-legged 8 mm. This is the symbol for diameter. Okay, 8 mm diameter at the rate 300 millimeter center to center. That means we are providing 8 mm diameter two-leg stirrups at the rate, means the spacing between the stirrups will be 300 millimeter center to center. Okay, and then in the last class I told you about something about anchor bars. These are the two anchor bars in which these stirrups are binded. Okay, so the diameters of the bars are 10 mm, and we have also designed the main reinforcement. Okay, and we have provided, I think, 20 mm diameter bars, and we have got that the number of bars was 3. Okay, so you can see here, this is the main reinforcement which we will provide in the tension zone. Okay, and the diameter of this bar is 20 mm, and this kind of bars we will provide in 3 numbers. Okay, 3 numbers of main bars will be provided at the bottom, and the diameter of the bar was 20 mm. Okay, so what is this? Can anyone tell me what is this? Can anyone tell me what is the what is this figure? Anyone? Can anyone tell me what is this figure? Okay, to Achumi, Benison, can you tell me what is this?
I don't know, sir.
Okay, Shiroda, top view. Okay, top view. And this is the cross section of the beam. Okay, if you cut the beam at any section, say if you cut, okay, so I will tell you how to see it. Because this is our front view. Okay, in the front view you can see only one bar. This side bar you can see, and this one bar you will see. But actually, how many bars we are providing and what is the diameter, if we have to check, then what we have to do, we will assume that we will cut the beam like this. At any section we will cut the beam like this, and we will observe from this direction. Okay, if we cut the beam along any section, and if you see from the perpendicular direction, then what you will see, you will see how many bars you are providing at the top, how many bars you are providing at the bottom, what is the stirrups, everything you can see. Okay, and what is the width of the beam, what is the depth of the beam, everything you can see. Okay, so this is the cross section. This is called the cross section of the beam. Okay, so I hope you understand this diagram. This means these are the two anchor bars, 10 mm. This is the two anchor bars. Okay, this dotted black dots are the anchor bars. Okay, the diameters are 10 mm, two anchor bars. These are the three main bars. This 1, 1, 2, 3. These are the three main bars. You can see here three numbers of 20 mm diameter bars. Okay, and this is the stirrups. This black one inside black line. This is the stirrup. Okay, this is the stirrup incline. This is the inside black line, inside one, not the outer one, inside one, this line. This is the stirrups. Okay, so can anyone tell me what is the meaning of this outer line, outer black line? Can anyone tell me what is the meaning of this outer black line, outer one, this one? Anyone? Outer black line. Beam surface. Wilson, Deberma, wooden box. No, not wooden box. Anyone? Any other answer? Virodha? Anyone have any other answer? Wooden box. It is not a wooden box. And you cannot say this is the surface of beam. Surface of beam mean what? Shiroda, Benison. Outer surface of the stirrup. Outer surface of the stirrup is the inside line only. This is the outer surface. This is the stirrup and the outer portion represents the outer surface. I am asking you what is this surface, this line, outer line, outer black line. What is this line? Outer black line. Anyone? Anyone have any answer? Anyone? Outer surface. Shiroda, this is the clear cover. Why don't you understand? This is the clear cover. This is the concrete surface. Okay, this portion is indicating your clear cover. The gap between the outer line and the inner line, this is your clear cover. Okay, and this portion will be filled up with concrete. This portion will be filled up with concrete, and the distance between the outer surface and the inner surface is your clear cover. Okay, So this is the problem which we have discussed in the last class. Okay, so today we are going to start the W reinforced beam. Okay, so today we will start W reinforced beam. Okay, so now I told you before also in the first chapter what is W reinforced beam. You can see here why W reinforced beams are providing. Why we normally provide W reinforced beam. The RCC beams in which steel reinforcement is provided in the tension as well as compression zone is called W reinforced beam. Okay, but you have to know in which conditions we have to go for W reinforced beam. Okay, definition, all of you know the definition, but under which condition we go for W reinforced beam, you have to know that. Okay, so you can see here sometimes due to headroom constraints or architectural considerations, the size of the beam is restricted and the beam size B into D is required to resist a moment greater than RBD square. That is the balancing moment. For a balance section, this was the moment of resistance RBD square. Okay, so now what is the meaning of that? Sometimes due to space limitations or architectural consideration also, we cannot increase the size of the beam. Okay, before going for the construction, we will first fix the size based on the requirement and then we will design. Okay, that means we cannot increase the size later on. So if the size of the beam is restricted and we have after doing the calculation for bending moment and moment of resistance, if we see that our beam has to resist a moment greater than the balance section, then in that case we will go for W reinforced section. Okay, so there are only two ways in which it can be done. That means if your beam has to resist a moment greater than for a greater than for a balance section, then we can design the beam in two ways. Either we can design an over reinforced section or we can design a W reinforced section. Okay, but the first choice is we cannot go for the first option because it will be a very risky. You can see here, and I have told you many times before that we will never design an over reinforced section because this kind of beam will fail suddenly, and you can see here it is and also it will become uneconomical, and the failure of these beams is sudden without warning. Okay, so we will never design an over reinforced section. So therefore it is better to use W reinforced beam section in such circumstances. Okay, the extra steel which will be provided in the tension and compression zone constitutes the additional moment of resistance. Okay, RBD square, that means this is the balancing moment, or for a balance section this is the value of moment of resistance. But in any case, if you find that our beam has to resist a moment greater than this value, then in that case we will go for W reinforced beam. Okay, so you can see what is the necessity of W reinforced beam. These are the different conditions. This theory portion I think I have given you before also. So this is the analysis of beam. Only you can see here, this is a W reinforced beam or actual W reinforced beam. So you can see here we are providing 5 bars in tension zone and we are providing 3 bars in compression zone. Okay, so now here in case of W reinforced beam you will get 2 effective depths. Okay, in the single reinforced beam we don't have these reinforcements in that compression zone, so we never got this D dash. Okay, but in case of W reinforced beam we will have reinforcements both in the tension zone as well as in the compression zone. Okay, so we will get 2 values of D. That means this will be known as effective depth up to the tensile reinforcement, and this will be known as effective depth for compression reinforcement. Okay, because this is our compression zone and this is our tension zone. Okay, so D will be your effective depth for tensile steel and this will be your effective depth for compression steel. Okay, so we can divide this into 2 parts. Okay, I'm not going to explain all these theory parts. Okay, so now in case of W reinforced beam, the depth of neutral axis you can calculate by this formula. By this formula, you can calculate depth of neutral axis. This is the formula you can remember, or I think it is given in IS 456 also. If you can go to annexure G, clause annexure G, all of you go to annexure G and you see whether you have got this formula or not. All of you go to annexure G of IS 456. I think it is the last page of IS 456, and you see whether you have got this formula or not. Have you got the formula? Have you got the formula, all of you? No, sir. Anyone got the formula? No. But the formula is given. But the formula is given. In this book, it is given in the simplified form. Okay, simply by simplification, they have give you the formula. But the actual formula is, you can see here in your IS 456, it is given. Mu minus mu lim equal to FSC into ASC D minus D dash. The basic formula is given. In annexure G, the basic formula is given. But this is the derived formula. So it will be better to remember this formula, because this formula is not given in IS 456. Okay, it is not given in IS 456, so it is better to remember this. X2 will be this formula. Okay, so in this formula, what is the you know the meaning of FCK, you know the value of FY. Okay, what is this FSC? F for stress, S for steel, C for compression. Okay, so FSC means stress in compression steel. Okay, so that means FSC means the value of stress which will be developed in the compressive steel. Okay, and ASC means area of compressive steel. Okay, ASC means area of compression steel, and FSC means stress in compressive steel. And the remaining things are known already. So next, you have to know what is how to find out moment of resistance in case of W reinforced beam. So this is the formula which is given in IS 456 also. Mu equal to mu lim plus FSC ASC into D minus D dash. Okay. Mu lim formula is this one. All of you know that because we have already used this formula so many times. Mu lim formula plus FSC ASC into D minus D dash. Okay. And this formula you can remember. The value of FSC depends upon the amount of strain in compression steel which is obtained from the strain diagram and D dash value. If you have to find out FSC, then we can find out first the value of strain in compression steel, then we can find out the value of, you can see here from the table, we can find out the value of FSC. FSC means stress in compression steel. Because this is our W reinforced beam, we will have reinforcements both in the tension zone as well as in the compression zone. Okay, so Fy value will be known to you. This FSC value will be unknown, and there is a procedure to find out FSC which will be discussed when we solve the numerical. Okay, but this is the general procedure. First we have to find out the strain in steel by this formula. Then with the ratio of D dash by D and based on the grade of steel, we can find out the value of FSC. Okay. Okay, this is the procedure to find out the moment of resistance. This is the procedure to find out the moment of resistance. Beam dimensions will be given to you. ASC, AST, types of steel and grade of concrete. If these things are given, then how to find out the moment of resistance, the procedure is written. Okay, first for the given steel and D dash by D, determine FSC from table number above. Next we will determine the depth of neutral axis. Then we will determine XU max and the type of beam by comparing XU and XU max. And after that, the moment of resistance of the section will be calculated by this formula. Okay, so if we get XU less than XU max, it will be under reinforced. If XU will be more than XU max, it will be over reinforced. Okay, these things we have discussed more than 10 times, more than 20 times I can say. Okay, so I'm not going to explain this again. Only the thing is that formulas are different in case of W reinforced beam. The remaining procedure is exactly same with singly reinforced beam. Only the formulas are a little bit longer or complex. Because in case of W reinforced beam, we will provide reinforcement in both the sides. Therefore, the formulas are different and the problems will be longer. In this case, in W reinforced beam, the problems will be a little bit longer. Okay. And the formulas will also be, you can see the formulas, they're also a little bit, what to say, complex. Okay, not complex, but if you want, you can, it's better to remember this formula. Formula means the value means formula for moment depth of neutral axis, because it is not given in IS 456. Okay, so let us see one example. So first, see the example 7.1. All of you see the example 7.1. All of you, please go through the solution, and if you don't understand anything, you ask me. Go through the solution, and if you don't understand anything, you ask me. Can you hear my voice, all of you? Please go through the solution, and if you don't understand something, you ask me. Otherwise, I will go to the next one. Because this is a very simple problem. Only you have to use the formulas. Just go through the solution. Can you hear my voice, all of you? Go through the solution. Do you understand the answer? All of you? Yes, sir. So can we go to the next problem? Okay, let's see the next one. Again, you go through the solution. Go through the, I have given you the PDF so that you can go through it. Okay, go through the solution. Example 7.2, go through the solution. Read the question first and then go through the solution. No? আৰু তাৰ কামতো দিছে আৰু গ্ৰিল দুইটা লাগিব আছে Do you understand example 7.2, 7.1 and 7.2 are exactly same? So I hope you won't have any problem with that. Then you go for 7.3. No. Basically, মানে খুব বেছিক আৰু তেওঁৰ এই হোমৱা জায়গাখিনি অলপ চকী কৰিব লাগিব আৰু আপোনাৰ এইটো হেৰিটো এই চকীটোৰ ওচৰৰ জায়গাখিনি যদি অলপ ডাউনে আছে এইখিনি আৰু দুৰ্বল মাৰি দিব নাই কি কৰিব কিন্তু খালি মাটিখিনি অলপ পেলাই থ'ব আৰু এই কি ক'ব আজিতো কাম নকৰে কালি আপোনাৰ এই আৰু কি কাম আছে বন্ধ ইটাখিনি জায়গা পাব না ইটা ইটাখিনি কি আপোনাৰ এই জায়গা পাব ইটাখিনি পাছ দিব ইটাখিনি জমা দিয়ে কিন্তু আপনি যদি একে আকৌ ইটাখিনি আকৌ আৰু আপোনাৰ ভৰিটো কওকচোন ভৰিটো পানী পানী উচিত পানী তোলাকে কৰিব ভিডিঅ' প্ৰথম ভিডিঅ'টা দিব তাৰপিছত পানী ওলাই আছে ওয়ালাইকুম সালাম পরীক্ষা করে কাম করে আছে আপনার আছে আচ্ছা এই রোটেট করে ভিডিওটা বলে বলে খেলা লাগে মনে